Okay, chapter 13. Last chapter we're going to do this year, guys. So, last chapter we were talking about force. Now we're going to be talking about how force affects motion. We talked about a couple things like air resistance, but the video you watched yesterday and the brain pop you did introduced work and power to you. So, we're going to be talking more about that today and how that's related to force. So, the first thing is defining what work is. So basically, work is force applied through a distance. And what that means is you're applying a force to move something. So remember we said that a force is a push or a pull, but also it can cause things to stay at motion or stay at still, basically, from not moving. Work is like if you're pushing something, you're the force that's making it move, but only while you're still pushing it. If you like push it and slide it across the floor, that's not work. You have to be applying the force throughout the entire distance of the movement. So, write this down, important. Two conditions in order for it to be considered work. Number one, the force needs to move the object, right? So, if you're pushing a bookcase, it has to move or else you're not doing any work. It also must move in the same direction. So if you're pushing it to the right, or you're pushing it up the stairs and it's falling down the stairs on you, you're not doing any work. You have to be moving it, and it has to be moving in the same direction. And this doesn't have to be like a person, it could be any force. I'm just using a person as an example. So this you don't necessarily have to write unless you just want the example, but here's just an example for you. So let's say that you are lifting a stack of books, right? You pick up the books and you lift it. You're the force, you're moving the books, you're moving it upward in the same direction that the force is being applied. You're doing work. But let's say you're holding those books down while you're walking. That is not doing work. The reason that is not doing work is because you're holding the books, right? So but you're moving, and the force that's causing you to move is your feet. Your feet are having no contact with the book right now. So the force is not in contact with the object and forcing it to move. Some more math and science. So let's say we want to start calculating how we find this work. How we're going to do that is the formula work equals force times distance. We learned from last chapter that the unit for force is newtons, and the unit for distance is meters, typically. You could use other metric units, but we tend to use meters in physics. The unit for any type of energy is joules. Work is a type of energy, so we're going to use the unit joules. All right, so force times distance equals work. But again, remember the algebra. If you wanted to find force, you could divide both sides by d. If you wanted to find d, you could divide both sides by f. So here is an example problem for you. Let's say you push a refrigerator with a horizontal force of 100 newtons, right? If you move the refrigerator a distance of 5 meters while you are pushing it, that is important. You need to be pushing it. How much work did you do? This is our formula for work, remember? So our force is the 100 newtons. Our distance is the 5 meters. Just multiply 100 times 5. That's 500. And our unit for work is joules, so that's a capital J. There you go. So now we have power. Power is the rate at which you convert that energy or use that energy. Remember, work is energy. So another way of thinking about power is the rate at which you do work. Power is measured in watts. Might be familiar if you think about light bulbs. You might see on the box like it's a 60-watt light bulb or so. So the formula for calculating power is energy in joules. So that energy could be work. It could be a lot of other types of energy we haven't talked about yet. But if you're trying to figure out power, it's energy divided by your time. That's going to be your power because it's the rate. So how much energy are you converting in a certain amount of time? So an example of this, you transform 950 joules of chemical energy into mechanical energy to push a sofa. If it took you 5 seconds, to move the sofa, what is your power? So important numbers, 950 joules of energy in 5.0 seconds. And it's saying, what was your power? Remember, when it comes to these word problems in math and science, you always want to remind yourself, what is it asking you? So power is energy over time. Our energy is 950 joules. Our time is 5 seconds. 950 divided by 5 will give you 190. And remember, the unit for power is watts. So that is where we're going to stop for lesson 13.1. If you're looking through your book, you might see a section there that also has mechanical advantage and efficiency. I typically teach that more with machines. So in the next lesson, when we get to machines, I'm going to throw that in there with it. I feel like it makes more sense there. So we're not just skipping it. If you're curious about it, we're just going to come back to it. So that's 13.1.